And laws of logarithms. Again, these stem directly from your properties of exponents. So if you do have a good grip on properties of exponents, laws of logarithms are going to be perfectly fine with you. Let's go through first of all and talk about what each law is. The product slash sum law says that if you have a log of the same base, you can, where they're being added, you can combine them using multiplication. So let's just say we have log base 2 of a, okay, and that's being added to log base 2 of b. Then we could combine those log statements to say log base 2 of a times b. That would be the product sum. You have the quotient difference law, similar idea. If I have log base 2, okay, of a minus log base 2 of b, I could combine those two log statements into one. That would say log base 2 of a divided by b. Now it doesn't matter what the base is, I'm just using 2 as a general number, okay, as long as the bases match is the important part. Last, the power law. This works both ways. That's the nice thing. All of these work both ways actually. So you can separate, okay, a log statement, or you can bring them together. So the power law says that if I have a particular number out in front of a logarithm, like a times log base 2 of b, that could be rewritten as log base 2 of b to the a power. And that goes the other way as well. If I have something with an exponent inside the log, I can bring that exponent out in front. It's actually what helps us solve those exponential functions from Algebra 2 that we were talking about earlier. So how are we going to utilize them? We're going to utilize them to simplify logarithmic expressions into one term. We're going to expand logarithmic expressions to hopefully simplify known quantities. And then we're going to solve exponential and logarithmic equations. So first, let's expand each logarithmic expression. So we're going to use those laws of logarithms. Again, it works the same as properties of exponents. If you see multiply, you add. If you see add, you multiply, so on and so forth. Here, I see multiply, okay, which means I can separate this using addition. This would be the same as saying log base 4 of x plus log base 4 of y. Here I have a power and I have multiplication, so we'll treat this one at a time. I'm going to do log base 3 of x squared plus log base 3 of y first. Okay, I don't want to do the power first because the power is not over the whole logarithm, it's only over the x. Then I want to use the power law and bring that 2 out in front. So I would simplify this another step, 2 times log base 3 of x plus log base 3 of y. And that would be my expanded form. Last, again, order is important here. I'm going to do the division first because both of the numbers in the numerator are being divided by the root z. Then I'm going to separate the multiplication. Finally, I'm going to do the powers. All right, so I do want to make sure I do follow an order there. So log base 3 of x cubed y squared minus log base 3 of root z. If you could do more than one step at a time, like really, some of you I think are capable to jump to the second step because you would have known that these two would be added. This is x cubed y squared minus root z. And then the last step would be to bring the powers down in front. So the 3 power is going to come out in front. So 3 log base 3 of x plus 2 log base 3 of y minus 1/2. Don't forget, a root is an exponent. Log base 3 of z. So that would be your expanded form. Okay? Good problems here. Let's try the other way. What if I give it to you expanded? I want you to bring it together. All right, I gave it to you expanded. I want you to bring it together. Let's see what that looks like. So I have same base. You got to verify that first. I see addition. So I'm going to bring them together using multiplication. Log base 5xy. Here I see subtraction and a power. So I'm going to put that power up first, and then I'm going to divide. So I'm going to end up with log base 3 of x minus log base 3 of y squared. Again, if you can skip steps, that's fine by me as long as you're getting it correct. And that's going to simplify to log base 3 of x divided by y squared. All right, and then we have the doozy here. Okay, let's go ahead and put this 4 up in the exponent. put the 3 up in the exponent, put the 5 up in the exponent. Once we've done that, we're going to have a numerator here that's going to be divided by, all right, that denominator. Okay, so, well, actually, it's only going to be divided by this one because there's no parentheses. So these two will end up being in the numerator. I'm going to do this all in one shot. See what you think. Log base 9 of 3x to the 4th and 3z to the 5th divided by y cubed. So that's all one shot. Okay, these two, all right, numerator, this minus puts these in the denominator, and I put each of the exponents in the exponent, or each of the multipliers in the exponent. Let's see how we act this out when we're evaluating or solving expression. Why do we need to know it? Why does it help us? What's it help us do? All right, so you know, I have all integers here, so this works out kind of nice. I can start combining things. So I'm going to end up with log base 4 of 32 divided by 2 plus log base 4 of 256. Okay, well that's nice because I know what 32 divided by 2 is. You see the advantage here, it's 16. So now I have log base 4 of 16 plus log base 4 of 256. So I could simplify that if I wanted to, okay, because I should know I should know what log base 4 of 16 is, right? 4 to what power gives me 16, okay? So 4 squared gives me 16 plus 4 to what power gives me 256. I might have to guess and check a little bit there, but if you do, you end up getting 4. 2 plus 4 is 6. So actually I could take that big long logarithmic equation or expression and simplify it to just one number. Sometimes things work out that nice. All right. Here I have same bases, 3 and 3. All right. I actually know what log base 3 of 9 is, so I want to go ahead and simplify that. That's 2. So I end up with log base 3 of x squared minus 72 equaling 2. Okay. Well, because I have a log equal to a number, I can change this out of log form into exponential form. Remember, the base stays the same. So 3 squared, the answer becomes the exponent, equals x squared minus 2, the logarithm becomes the answer. Advantage, well, 3 squared is 9. Subtract 9 from both sides, I get 0 equals x squared minus 81. I can factor the x squared minus 81 because it's difference of squares. So that's x minus 9, x plus 9. Now I'm going to throw in zero product property from algebra 2 or algebra 1, and I'll get 9 and negative 9 from my answers. All made possible by laws of logarithms.